Hello everyone. Today I'll be briefly showing you how to collect powder X-ray diffraction data on low-dimensional nanomaterials. To minimize the preferred orientation effect for 1D and especially 2D materials as we see here, and to perform meaningful Rietveld or Lebesgue refinement, materials must be prepared appropriately for powder X-ray diffraction or PXRD. So we can go from plots like those shown on the left to those shown on the right. Some of these materials, if ground at room temperature, will merely have their layers slide across each other and not ground properly. To prevent this, we can introduce an amorphous material to help break up the weak interactions holding the larger crystals together. One material that we have plenty of is this amorphous quartz glass. On a safety note, we'll start with appropriate eye and hand protection. We'll start by grinding it in a mortar with a pestle, reducing tubing to a fine powder. Starting with a small section, piece of amorphous quartz glass inside of the mortar, using the pestle to gently and carefully break it up. In a comparatively short time, we're left with a couple of large chunks. You can start to see how it turns into a fine white powder. After grinding for several minutes, you will have a powder of uniform size. Recover that because you're going to have more than enough for several runs left over in a secondary container. Run it for yourself to confirm its amorphous nature. You should see the amorphous region prominently between 10 to 30 2 theta when using a copper source as we did, likely with the highest intensity approximately in the 22-23 range. For a reference point, it may be worth running this material as single crystal XRD samples to know which planes are present within the pattern to get a feel for the preferred orientation effect. This scan is still going, but I have 3 one-dimensional wires unground on the mount, and you can see that there is clear preferred orientation effect. Before grinding your material, make sure that you have a small mortar and pestle cleaned. Next, we're going to select a reasonable mass of the material that you want to grind. I'd recommend somewhere between 8 to 30 milligrams for 2D materials, and somewhere as low as 1 to up to 30 milligrams for 1D materials, based on the experiences that you might have with the different materials and what kind of mount you have. Set it aside, note the mass, and weigh out as close to half a mass of that for the quartz powder. For example, I'm looking at 2.1 milligrams for this particular 1D material. I'm going to try to weigh out approximately 1 milligram of the quartz powder. Right now we have slightly more than 1/2 the mass of the crystals that we're going to be grinding with this powder. Here we have the crystals and the quartz powder in the mortar ready to be ground with a pestle. The before, and here we have the material after grinding. Grinding can be underdone and it can be overdone. I ground it until I no longer saw any of the wires obviously visually present. So we have a pretty homogeneously uniform powder that has a flour-like texture. Just fine enough that you cannot feel grains anymore. We have just started our run. You can see that the 5 value is 15 revolutions per minute for the slide itself. We are still running at the 5 to 65 2 theta range. The runtime will last just under 1 hour with a time step ratio of 1 second, just under 3,000 steps. Total time just under 1 hour. I'll see you when we get to the other side. We're just about at the end of that 1 hour run that had the ground samples. We see the same peaks that we saw before, but we also see other peaks That's with the preferred orientation effect being taken into account of the unground samples emerged that had previously been dominated. Using this pattern, we should be able to perform Rietveld or Labelle refinement. For comparison's sake, I'm also going to try a substantially larger sample. So here we're looking at 10.7 milligrams of the crystals. I'm going to weigh out slightly over 5, maybe close to 6 milligrams of the quartz, grind those together and run that. And we're currently looking at that second ground material run. The second ground run has concluded, and if you recall what the intensity was for the first one, we're seeing substantially larger peaks and the same quantity of peaks. So for this particular material, it appears that using the larger quantity definitely will lead to a cleaner pattern that should still be able to be solved by Rietveld or Labelle just as easily or slightly better than the first one. The collected pattern can now be refined in programs such as Fullprof or Topaz, the latter of which we see here. Thank you very much for watching. Let me know of any questions, comments, or concerns.